We can see millions of stars when we look up at our night sky. But what can we tell just based on their brightness or their color? How do we keep track of them all? This week on Space But Messier. Over 2,000 years ago, the Greek astronomer Hipparchus was the first to catalog stars based on their brightness. However, with modern cameras, we've learned that we can actually measure the amount of light that enters the lens. With this, we've learned that the brightness of stars is not random at all. In fact, a star's size, temperature, and brightness are directly correlated. We measure the brightness of stars in two ways. First is the apparent brightness, or apparent magnitude. Just as Hipparchus did, this is a measure of how bright an object appears to be to an observer. But what about their distance? We quickly learned that fainter stars that are closer to Earth could appear brighter than a far brighter star that's much farther away. The second measurement is the true brightness of the star, or the luminosity. This is the amount of energy that radiates from the star in all directions per second. This measurement is unchanging, and it's also called the absolute magnitude or the absolute brightness of a star, and it's far more accurate when measuring the brightness of stars. We use these measurements to classify all stars on the Hertzsprung-Russell diagram, or the HR diagram. The x-axis represents temperature or spectral type, and the y-axis represents luminosity or magnitude. For instance, if you take all of the stars at the center of the globular cluster Omega Centauri. First, we'll sort them out by color, blue on the left and red on the right. Then we'll sort them out by brightness, brighter stars on top and fainter stars on bottom. The final image represents different potential stages of a star's life. Stars spend most of their life on the main sequence. Then, when their fuel runs out, they expand to become red giants. Then with helium as their new source of fuel, they can burn blue hot and eventually burn out as a white dwarf. And this is how we classify all the stars we see in our very own night sky.